So it's actually trademarked, you legally can't use it.
Well, we weren't gonna use it. We weren't gonna use it.
I'm already suing you over stabbing me, okay? Don't make me sue you twice.
Stabbing? You stabbed him?
Salted me.
Don't keep using it. We're gonna use it.
No, I'm gonna stay with Drew because I don't want to be stabbed for doing nothing.
I don't know that Drew's gonna prevent you from being stabbed. I mean, really, it's Drew.
No, Drew's gonna get me into situations.
This is true. He's good at that kind of thing.
Other.
No, we're the other founder of Pluto. Period, okay? We bought Pluto, okay? It's no longer playing out $7 in a box of used stuff. Or a handshake and a hot coffee. What? It's information you're spreading, okay? Pluto world.
Hey, guys, not so loud.
Preemptively strike. You get half the planet for Pluto World, we get the other.
Yeah.
No.
Yeah,
Wait,
you
but
get
we
100%
get new-
planet.
new buy-
Alex, too much misinformation is being spread on Pluto. It might-
Hold on, I got a flippy hat.
We'll just, I don't know. Turn the entire planet.
You know what's funny would be if they have their whole scheme and then you do a knockoff scheme.
Okay, for guys, shh. For Sky who is listening, Sky, what we're gonna do with this week's lab is I am going to close that, I'm sorry. I am going to put out a procedural thing to kind of show you how to do all the equations if you choose to do them and you turn it in next week. I'm gonna set it at 105 if you get them all right. If you don't get them all right, but you've tried, it's probably gonna be like 102.5. If you don't turn it in at all, then it's not going to count against you. I'm gonna make it as an extra credit because it was way too long for some people for this class and above some people's math levels. Okie dokie. So let me go back to my other one. All righty, it is noon. Are we ready to roll? Folks, are we good? All right. We are in our last, well, second to last unit. Your final project, Alex, your final project counts as a unit, right? But we are in our second to last unit, which is Sun, Moon, Earth system. And we do get talking about stuff past that soon enough. All right, so first thing I want to go back to is this. Okay, compare and contrast. This shows up on your tests sometimes, and some of you have had little issues with this. So compare and contrast. Compare is part of the question. Y'all are great at contrasting, but some of you straight up forget about comparing. So let's look at a banana and a lemon. Oh, it's a Venn diagram. Venn diagrams are great, right? You got a banana and a lemon. If we compare them, what are they? They're both yellow and they're both fruit. That's comparing, right? Banana, smooth and sweet. Lemon is sour and bumpy. Okay. That's the compare part. Now, does it seem painfully obvious and ridiculous and stupid? Like if I say compare relative age dating and isotopic age dating, and it's like, well, both tell an age. Yeah, but guess what? That shows up on tests sometimes. And especially on when you get to your standardized tests, you may run across compare and contrast. Don't forget the compare part, even if it seems painfully stupid. Yes.
Also, fun fact about bananas, they're a berry.
Yep, they are a berry.
They're the largest berry in the world.
Are they?
And the reason that artificial banana doesn't taste like real bananas, artificial banana tastes like old banana that has now gone extinct, is replaced with this banana that is resistant to the disease that wiped out the previous banana.
Yes.
Okay, then.
No.
All right. Well, that's interesting. Thank you.
Star symbol.
No.
2010, the more you know.
That's an interesting one there.
So old banana is what banana flavoring tastes like banana, just not the banana we know. It tastes like a previous banana that was wiped out by disease. Our banana was designed to not be weak to that disease, so it can survive, and we can still have bananas.
Okay, cool. That's interesting to know. If you've ever seen like, I know we talked about it a little bit last year about, genetic engineering and whatnot of fruits and vegetables that we farm. Banana is one of those ones that, like a wild banana that hasn't been manipulated in any way is not at all what you're used to seeing. Yeah, big giant seeds in it, not those little itty bitty ones that are in our bananas. So let's have a look here. We're going to talk about some tools of astronomy. And the first thing, radiation. Now you gotta love Doc Brown. Who doesn't love Doc Brown? All right, so
People that tried to kill him.
yes, the Libyans. Oh yeah. All right. So what do we call the electric and magnetic disturbances? Yes, Bailey. Yeah, electromagnetic radiation. That's right. Okay. So is there electromagnetic radiation in this room?
Yes.
Yes.
I call it light. And
Yep.
It's kind of important for human.
It's everywhere. Hey, guys, come on. All right. So all types of electromagnetic radiation that we arrange by wavelength and frequency, we call what? All right, Alex, you take this one.
Electromagnetic spectrum.
Yeah, okay, electromagnetic spectrum. Now, this will be something we talk about a lot in physical science. But basically, you have this whole spectrum, and this little bit right here is the only part of it we can see. There's all kinds of stuff we can't see. Who's had an X-ray before? Any kind of X-ray, a dental X-ray?
Yeah.
There you go. So
I had a chest X-ray before.
there you go. So your
I had a leg-
X-rays. So if you look here, your X-rays are over here. So they are past your ultraviolet. Now, when we look at this wave, which we're going to talk about next, you've got a couple things going on. You have your wavelength, which is how long it is between these crests, and you have your frequency, and that is how much or how often one of these crests or any other point on the wave is going to pass through a particular point in time. Okay, so you can think of it kind of like speed, but it's not really speed. All right. So our sunlight is in here. Microwaves. My microwave running? Yep. Microwaves are going to be over here. Radio. If you listen to radio, it's over here. All right. So wavelength. So we've got a couple of things that go on with wavelength. We've got a green line, a red line, and a blue line here that is our wave. The red one is describing the distance between identical points on consecutive waves. So that's the distance from here to here. And what do we call that, Bailey? That's our wavelength, right? Call that our wavelength. So, think. Oh, look at it grow. That's cool. Yay. That's going to be our wavelength. And then the distance between the origin and the crest. So from here to here is, Caitlin? Right? What else do we call it? From here to here. From here to here. See it? That's our amplitude. The amplitude, yeah, is the height, basically. It's from your point of origin, which is your middle here. Ding, ding. All right, and then this last one is the number of times it passes through a point per unit of time, which is kind of like I said, think speed. And Jack, that's what?
Frequency.
That's your frequency, right? Okay. So wavelength, frequency, amplitude, they all have different applications when we are using them. How do I say it? When we're finding a practical way to use waves. Now, light is different. Do you remember why light is special?
It's a particle.
And a wave. It's a particle and a wave. Now, next year we'll talk about, in physical science, we'll talk about waves, and there are different kinds. You've got waves that go this way, and some that go like this, right? And we'll talk about sound versus light, and it gets kind of involved. So the reason to know this is because we use this information to determine all sorts of things from space. And some of that is information we're going to get from telescopes, and we're going to combine that, especially information that we get from other things. But telescopes. All right. So what do we call bringing light to a visible focus? Do we know? Do we know? Yusuf.
Refracting.
Refracting. Oh, it all went away. Sorry. They should have gone away one at a time. So refracting telescopes, this is an example. It's going to bring light to a focus. So it's going to take the light. There's an objective lens. You got light coming in this direction, and it's going to bend it here. Okay. Reflecting telescopes bring the light to a focus by using mirrors. Bing, bing, right? And then interferometry. That's using image from an array of telescopes to form a single image. So do you guys remember the black hole picture that came out like 2 years ago? It was a big deal. Okay. So, oh yeah, it was pretty neat. So yeah, basically what they did is they took information from multiple telescopes and computer data and used it all to create a visible image that we could understand, because the data that came in wasn't visual data. Yeah. So let's talk about telescopes for a minute. So Hubble was what we had going for years. It was the telescope. So Hubble Space Telescope is about as big as a school bus. It weighs 24,500 pounds. That's just under 2 adult male African bush elephants, if you were curious. It gathers energy from the sun using 2 25-foot solar panels. It requires much less power than you might think, averaging 2,100 watts of power usage. A hairdryer uses 1,800 watts. So it's not using a ton of power. Hubble orbits Earth at a cruising speed of 17,000 miles per hour and takes 15 minutes to rotate 90 degrees. It
orbits once an hour.
17,000 miles per hour. Yeah, 15 minutes for 90 degrees. So yes, once an hour roughly. Yeah. So Hubble has observed locations more than 13.4 billion light years away. What's a light year? Wait a bit. What's a light year? Drew.
It's the distance that light travels.
Yeah, or the time it takes for light to travel from its point of origin to where you can see it is in a year. If you were a year away, that's kind of hard to explain. But yeah, you said it better than I just did. So 13.4 billion light years away, meaning it has seen light that existed in the universe 13.4 billion years ago. And astronomers using Hubble data have published more than 13,000 journal articles, making it one of the most productive scientific instruments ever. And these are some Hubble images. Pretty cool. Yes. So also there was an issue when Hubble went up with the mirrors, and they had to send an astronaut up and do a spacewalk to readjust them. So here's Hubble. Ooh, come on. It's supposed to be, oh, there it goes. Okay, yes, it's supposed to be a video. Here,
Hubble trouble.
here, Hubble trouble. Oh, hold on, you can't hear that. Be louder. Oh, where'd I put it? Here it is. Because Dr. Brown was really loud, so I had to turn it down. He was screaming at us, right, Scott? I don't know why, but he was.
Welcome to a virtual tour of the Hubble Space Telescope, our window to the stars. Which launched into space in 1990, circles the Earth 15 times a day, gazing into our vast universe.
15 times a day,
Coming in at about the size of a school bus, Hubble flies 340 miles above Earth's surface. It travels at a speed of about 5 miles per second. Hubble's position beyond Earth's atmosphere gives us a clear view of cosmic objects. The Hubble Space Telescope has several science instruments that allow us to study light. Behind these doors, you'll see the Space Telescope Imaging Spectrograph, the Advanced Camera for Surveys, and the Cosmic Origins Spectrograph. Hubble can see visible, ultraviolet, and near-infrared light with these instruments. Scientists observe these different wavelengths of light to learn about chemical content, temperature, density, and motion. This light can help us learn about the evolution of galaxies, stars, dark energy, and dark matter. Now, you see the Wide Field Camera 3. This instrument was upgraded on the last servicing mission to Hubble and is the most technologically advanced instrument on board. Coming to the top of the telescope, you can look down and see Hubble's two mirrors, which are made of special glass with reflective coatings. The large primary mirror collects cosmic light and reflects it to the secondary mirror. The secondary mirror bounces the light back through the hole in the primary mirror and into the telescope's instruments. As a safety precaution, Hubble's aperture door can close to prevent sunlight from entering and potentially damaging the telescope or its instruments. That glowing ring is Hubble's soft capture mechanism. It will allow a robotic mission to safely move Hubble out of orbit when the telescope retires. You can also see two large solar panels. The panels collect sunlight and convert it to electrical energy, which is then stored in batteries and used to power the telescope. Hubble also has 3 fine guidance sensors that allow the telescope to point, lock onto, and measure the position of stars. Once light is processed, the antennas beam Hubble's images and data to communication satellites. Then, those signals are sent to stations on the ground. The ground stations transmit the data to NASA's Goddard Space Flight Center in Greenbelt, Maryland. After it's processed, scientists will study this data and share their findings with the world. We hope you enjoyed your tour of the Hubble Space Telescope.
Hope you enjoyed your tour.
For more information,
So, oop, did I miss it? Nope, I didn't. Okay. So this Hubble telescope, 1990, right? Went up in 1990. And it orbits, there it is, 97-minute cycle, still active. Okay, still active, 1990, that's good. We have something that's been out there about 47 years. Do you know which one that is? It's not a telescope, but Oh, no, not ISS.
47, that would put it back in the late 70s, what,
Mhm.
76-ish?
Yeah, it was instrumental, but it wasn't. Yeah, it's roughly went out around the time I was born, so it's easy for me to remember how long it's been out there. Does anybody know? Do you know? Piper?
The National Space Station?
No,
No.
do you know?
Voyager?
Voyager's the one. Yep, Voyager's been out there pretty much since I was born. Still going. It's still going. Where would you find Hubble in this room?
Right there.
Nah, besides the TV, where else would you find it? Who's that? That's Edwin Hubble. All my fish are named after scientists. You might want to remember that. Might help you on an exam. Anyway, now we have James Webb. James Webb went up in 2021, and James Webb makes Hubble look like a joke, which is crazy because Hubble's awesome, but James Webb is like crazy nuts. We've been able to get some really, really good pictures with James Webb. And when you compare one to the other, which we're going to do in a minute, you'll see the detail and the granularity of James Webb is so much cooler. So this is what Webb looks like. It's funky looking, right?
Like the Millennium Falcon. But
Yeah, it kind of does. It looks like something out of Star Wars for real.
Pizza slice walking.
So here's your Webb. So James Webb,
it looks like some kind of laser.
yeah, is currently conducting infrared astronomy as the largest optical telescope in space. And it's equipped with high resolution and high sensitivity instruments, allowing it to view objects too old, distant, or faint for Hubble to see. It enables investigations across many fields of astronomy and cosmology, not cosmetology. Anybody ever made that mistake? I know a boy, a high school boy that signed up for cosmetology class because he thought it was cosmology. And he was really shocked because that was his elective. So he spent a semester doing cosmetology, which is basically beauty school, right? All right. So fields of astronomy and cosmology, such as observation of the first stars, the formation of the first galaxies, and detailed atmospheric characterization of potentially habitable exoplanets. The first full color images and spectroscopic data were released on July 12th, 2022, just this last summer, remember? Which also marked the official beginning of Webb's general space operations. So Joe Biden revealed the first image, which was called Webb's first deep field, right? You've probably seen it. You'll recognize it when I show it to you in a minute. And that was on the 11th of July, 2022. So here's our milestone for
we got together and looked at the very first diffraction limited images that came out of the Webb telescope. And what we collectively saw as a group is we have the highest resolution infrared images taken from space ever. So you think it was a blob on a picture, you know, but it is extremely high resolution. We have exceeded every expectation. The telescope is performed better than the models said it should. We've even achieved, we talked about resolution and wavefront quality. We've done better in those regards than we thought we would do, and we're just thrilled with that. And to get there, we went through a process. Well, we did the segment identification, and then we formed the image array. And then once they were in the image array, we used this phase retrieval technology to position each of the mirror segments and the secondary mirror itself such that all the optical aberrations were effectively eliminated. We tilt the mirror segments to bring the light from each mirror so that it falls on top of each other at a common point in the middle of the detector. And we call that image stacking. And that concentrates all the light in a single place, but the segments themselves are not cooperating. They're not working together at that point. They're all their own individual telescope. And the next phase of the process is something we call coarse phasing. And that's where we adjust, well, literally it's the piston. It's the up and down motion of the mirror segments relative to each other. We control the piston of the segments so that they all come together in creating a complete monolithic primary mirror. If you know exactly what the shape of that telescope is, and you know exactly how the light is falling on your detector, it turns out you can actually prove mathematically that that is enough information to tell you exactly what you need to do to that telescope to fix the alignment errors. And why do we know this? We know this because of something called a pupil imaging lens.
So
And this
the,
allows us to take a picture of the primary mirror of the telescope. People have referred to it as a selfie. Well, that's what it is actually. But that's really important mathematically. Now, there's a catch, however. Just because you know a solution to something exists does not automatically give you that solution. And that is the difficult part. That's what we've spent 20 years working out. It's highly mathematical, using something called Fourier analysis. But that's what we do is we tease out those solutions and we find what we need to do to each optical element to achieve perfection. We then turn to a different way of doing phase retrieval across the entire aperture of the telescope at the same time. And for that, we're not going to take the telescope out of focus. Instead, we have some lenses that are in one of the science instruments that we use to automatically create a defocused image. And we look at these images and take it as a whole. Then we can tell the last little bit of alignment errors that are in the telescope that we need to fix. And that's what we accomplished today. We analyze those images and we apply the corrections leading to the diffraction and the perfect performance of the telescope. So there's only one thing left to do, and that's to see how well the telescope is aligned in the other science instruments. And we'll check the alignment there, and if necessary, then we'll apply a solution that optimizes for the entire telescope. We then periodically measure the alignment of the telescope and make corrections as necessary. I cannot wait to see what it discovers.
so if you're super mathy and you like space, working on a telescope like this would be a great job for you. It's pretty crazy. So here's what we get. This is an image from Hubble. All right. Same image from Webb. That's Webb's deep space. And you can see how much better. Yeah. I mean, that's incredible resolution. So when this is the image that came out this summer. This is the same. They're looking at the same thing here. And you can see, like, see this star is this star. Bing, 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 bing. Yep. You can see this kind of shape comes through here. And here it is here. But you can see how so many other little pinpoints of light are visible here that don't even show up with Hubble. And Hubble was, like I said, pretty darn amazing. So when you compare the two, you can see how far we've come in, well, 1990 was what, 30 years ago, 35 years ago? Yeah. So in that amount of time, and they worked on Webb for 20 years, we were able to get this much more resolution, which is amazing. Actually, the same company that makes this dress I'm wearing today makes a deep field one that I want to get too. It's pretty cool. All right, so We also have spacecraft and human space flight, and there's our Voyager, okay? So it was launched 77, so I was a year old when it launched. So it's been out 46 years, and it's the oldest computer in space. And in 2019, it became the most distant from Earth of all known human-made objects. It's just going. Yeah, it's gone. This is Voyager. Here's the crazy thing. It's heading out of our solar system as we speak. Or
Still
it's,
working?
yes,
Mhm.
it's still sending data, which is really impressive, really impressive. And then we have this. Where did we talk about this recently? Al Gore talked about the blue marble. There's the blue marble. There it is. So 1972, it was photographed by the Apollo 17 crew, and it's one of the most widely reproduced images in history. And one of the few to show an almost fully illuminated Earth as the astronauts had the sun behind them. Usually when they take pictures, part of the Earth is in night, right? So this one was special because
Still really cool.
it's really cool. Yeah, really, really cool. Okay, yeah. All right, so from space, we've gotten a lot of spin-off technology. I tried to find a better resolution picture, but it was hard. So NASA has given us so much stuff that we don't even realize every day. Like, and who has an example? You have an example?
I believe.
Hmm?
There's, I believe, a specific type of tape or glue that was designed.
Yeah, that kind of stuff. Uh-huh. Yeah, there's a good example. What else? What do you got back there? Velcro. That's a big one. Yep. Who uses Velcro nearly every day? No, I use almost every day for some reason. What have you got, Bailey? Have you got one? Or you were gonna say Velcro? What? He said that. Yeah,
Those were actually never.
they were
taken into
before,
space.
but they used. Yep, they took them to space. Uh-huh.
They were never taken to space.
Oh, they weren't. No, the food, the freeze-dried food was, but not the astronaut ice cream. Uh-huh.
Space pens.
Space what?
Pens.
Pens. Yes.
Pens.
Yes.
with Pressure.
You have to
put
write in
behind-
zero gravity. How do you do that?
If you
Yeah.
pressurize behind the ink, so it pushes forward.
Right,
It's
ink's
also
pressurized.
up-
Wait a minute, Bailey was trying to talk. What is it? Yeah, all kinds of stuff. So if we look here, here's some examples. All right, and some of this is just craziness. You don't even think about it. So we've used NASA technology with air conditioning, water purification, food processing, wireless stuff, all these different satellite things like satellite weather and mapping and all of that, solar power, broadcasting, microchips, right? Goodness sakes, there's microchips everywhere, right? Better brakes, better robot guided wheelchairs. Look at that. Yep. Those space blankets, the little foil blankets that you find like EMTs will use. Yeah, they're like-
Alexa, she'll roll you downstairs.
Yeah, a lot of the times they'll be in like they'll be in first aid kits because you can fold them up like a piece of paper, but then they cover a whole person.
And they're also very warm.
Yep. Insulin pumps. The technology that for insulin pumps came from NASA technology. Infrared instantaneous thermometer. You know that one that I point at stuff in lab and it goes beep.
Beep.
There you go. Uh-huh. Yeah, I said that one over here. Yep, and then all kinds of like shock absorbing things and all this stuff. This is CAT scan technology, laser surgery, ultrasound. Like all these things were either invented or vastly improved by NASA or by just space exploration in general. All right, so ta-da, wearing my dress today. Now, exploring the moon, space probes. Which Apollo was the one to land? Okay, Chloe, here we go. All right, Apollo 11, which was Armstrong, Neil Armstrong, Buzz Aldrin, and Michael Collins, right? Okay, so an astronaut footprint could last 1 million years on the moon. There's my footprint, where is it? Oh, there it is, boom, ha! I dressed for the day. If Apollo 11 had failed, President Nixon had a speech ready. Now, here's the thing. This is a moment when the world stopped. Like literally everybody in the world. Yeah, well, some people still think it was fake, but they're crazy. Anyway, people all over the world, America and not America, all were in front of a TV because everybody wanted to see this, but they had, your average Joe had no idea what was going to happen when these guys stepped out of the lunar lander, the Eagle, right? No idea. People were afraid they would burst into flames. They would instantaneously die. They would explode. People had no idea. People were terrified that something, yeah. So Nixon had a speech ready. And so Buzz Aldrin took communion in the lunar lander, which we're going to talk about in a minute. It's a very, very interesting fact. So in all, 12 people have walked on the moon, all of them American astronauts. Armstrong and Aldrin spent almost a full day on the moon's surface. Michael Collins never left Columbia. He stayed in there and orbited the moon. And poor guy got to watch everybody else go. After returning to Earth, the astronauts had to be placed into quarantine because we don't know, maybe they got a moon disease and they're going to kill everybody. Or maybe they're like full of radiation or something and they're going to cause everybody around to have cancer. So the moon contains flags from the US, the Soviet Union, Japan, China, and India. And Armstrong carried with him, a piece of wood from an airplane that belonged to the Wright brothers. So, did you have a question or a comment?
Buzz Lightyear is based on.
Yeah, Buzz Aldrin. So Buzz Aldrin, we're going to talk about Buzz Aldrin for a minute because Buzz Aldrin doesn't get enough street cred these days. This is one of my favorite Buzz Aldrin moments. So 30 Rock is off now, but it was an NBC show with Tina Fey. And there was an episode with Buzz Aldrin, and it's just outstanding.
Big factor with respect to space and space exploration.
This is Buzz.
At some point in the future, we'll look back and say, how did we do it without space? The future of American space leadership, we're going to lead again. It's been a long time, so 25 years. Today, we're taking a crucial step to secure America's future in space by reviving the National Space Council after has been dormant almost 25 years, if you can believe it. Today's announcement sends a clear signal to the world that we are restoring a proud legacy of leadership in space.
I feel like he knew what he was doing.
Down space.
Now, Buzz Aldrin has sued his own children.
I mean,
News exclusive, astronaut Buzz Aldrin is suing his own children, saying they're trying to steal his money by claiming he has dementia. Last month, 2 of his children filed paperwork to become his co-guardians. This will give them control of his finances. They say that Aldrin is in cognitive decline and is paranoid and confused. However, he underwent a voluntary mental evaluation earlier this year, which found the opposite. Aldrin claims his son Andrew transferred nearly $500,000 from his bank account to Andrew's account.
Family is forever, and I will forever be compassionate.
His children say that they are saddened by the unjustified lawsuit and hope they can resolve the situation.
So here's another example of why he's national treasure. Now I'm gonna warn you, there's gonna be a swear word in here, but you're gonna survive it. Okay, I apologize ahead of time. Now, context. Wait, listen, context. Buzz Aldrin is walking out of a hotel and he gets caught by one of these guys who believes the moon landing wasn't real and it was it took place inside of a sound stage or whatever in California. And he goes up and he starts asking Buzz, did you really land on the moon? Don't lie, don't lie. And well, this happens and it's pretty amazing.
Why don't you swear on the Bible that you walked on the moon? Why don't you swear on the Bible that you walked on the moon? Get out of here. Believe you know. You're the one who said you walked on the moon when you didn't. Calling a kettle black if ever thought of saying that. Get it away from me. You're a coward and a liar and a thief. And a thief, and a thief, and a thief, and a thief.
Yeah, there you go. Yeah, he punched a guy in the street. He got tired of him. He got tired of the lip, so he knocked him out. No. Move on. So why is Buzz so angry? All right. He's dealt with a lot, like he was telling Liz Lemon in 30 Rock. He did have some, alcohol issues for years and stuff. He struggled a lot in his adult life. But first, okay, these Apollo 11 astronauts were quite literally prepared to die, right, for this mission. So, here's a guy coming up to him on the street. You lied, you're a liar, you're a cheat, you're a whatever. Swear on the Bible, he says. Well, why does that matter so much to Buzz? Buzz Aldrin is a man of deep, deep faith, and he took Holy Communion on the moon, and NASA kept it quiet for years. Years. He took communion on the moon, bread and wine, communion from church. And this is actually the chalice that he took to the moon. And it says, this lunar module PPIT carried my personal belongings to Tranquility Base on Apollo 11, including communion kit. So Buzz Aldrin read from John 15:5 when he landed on the moon and 50 years ago. And it said, that's the part that says, I'm the vine, you are the branches, whoever remains in me and in him, I will bear much fruit, for you can do nothing without me. So he read that, and I know that guy's crazy. He read that and he took communion on the moon. Now, this is where NASA gets a little kooky. Okay, stop doing that.
Meaning is zero G, things like
Yeah.
that experience.
Every year, his church, which is Webster Presbyterian in Texas, holds lunar communion on the Sunday, lunar communion Sunday on the Sunday closest to July 20th, which is when they landed on the moon. So if you were ever near Webster Presbyterian Church, near July 20th, they hold a lunar communion Sunday where they celebrate lunar communion, which is pretty darn cool. NASA kept the lunar communion a secret for 50 years. Why? Anybody know why? Want to guess why, Bailey? A good guess. Anybody else have a guess? Milo. Not everybody believes in his religion. Yep. And NASA, is NASA a private organization or what? Nice. Yeah. NASA's funded by our taxes, right? Uh-huh. Yeah, it's governmental. All right. So here's what happened. All right.
It would make
What?
it would make it look like.
And we went by too fast.
It would. Yeah.
So here's why. I'll tell you why. Basically, when the first missions took the picture of the blue marble, they read some Bible verses. Does anybody know what they read up there? This is when they were broadcasting the picture to Earth. They read from Genesis, which is the first book of the Bible that talks about how the world was formed. Okay. They read from Genesis and showed pictures of Earth when they broadcasted down. A lot of people were not happy with that because it's a government organization. It's tax funded. They shouldn't be reading from the Bible, this whole thing. And they actually got sued. There's a lady, I can't remember her name in particular, but she sued them, got real kinds of mad, all kinds of mad. So Buzz desperately wanted to take communion to the moon because he thought it was a moment of great importance. And as a man of faith, he felt that that's what he wanted to do before he stepped out on a planet. He might die. The last thing he wanted to do was have communion, which makes good sense, right? And NASA kept it secret for 50 years because they didn't want to get sued again. Yes.
Depending on who read the Bible verses, I'm not sure that they could legally be sued for breaking the separation of church and state because it would be would have been read by an
Right.
employee, not a person like power.
But he represented the organization, which is the government.
Buzz Aldrin joined Eminem's mom for parents suing their children.
Oh, there you go. Parents suing their children. Okay, so let's talk about the moon for a minute. I walked on your face. So let's talk about the moon. Albedo is the Latin word for white. Also albus, as in an alb, which is white, or, this guy right here. Recognize him? All right. So I love that. You seem to be laboring under the delusion that I'm going to, what was the phrase? Come quietly.
Yes, he's
Mhm.
he set him up to die.
Yeah. No, he literally.
Oh, we're going to get into a Harry Potter argument. Okay, back to this. All right, so Lunar Highlands. These are heavily cratered, light in color and mountainous. All right, and then the Maria, not Maria, but Maria. These are your dark, smooth plains. Now here's another good Latin root. Maria, mare, mare, means sea, as in, you know,
Mermaid.
a mermaid or a marine. There you go. All right, same roots. All right, so these are all different parts of the moon where they get their names. We love our Latin roots. We got all these little areas. All right, so we have impact craters on the moon.
Sushi on the berry.
And then the things that get thrown out of the impact crater is the ejecta. So when the moon gets hit by, guys, when the moon gets hit by, well, you know, but it also could be like a meteor, right? When it gets hit, boom, you get a crater, but then stuff comes flying out of the crater, and that's the ejecta. And then these long rays, you can really see them here. These are trails of ejecta. And then these riles, see these? These are called riles.
I see a burning point.
Where?
Right, log trails.
Oh, should say long. You are correct. Wow, good one. L-O-N-G. Whoops. These are, so here's your crater, here's your ejecta, and there's your, now these riles. What are these things? Doesn't this look like maybe where water would flow?
They look like tapeworms.
They're not really sure what they are. They think they're collapsed lava tubes, but they're not.
Tapeworm.
Yeah, okay. They're not 100% sure what they are. It's kind of weird.
They're ancient alien war trenches.
Kind of weird, kind of different.
That's what they are.
So what is the moon mostly composed of?
So
Specifically, Caitlin?
cheese is made of cheese
You know,
and stone.
silica is right. Silicates, very good. All right, mostly composed of silicates. And it is similar to Earth in that it has a mantle, a crust, a mantle, and a core. All right. And here are your rough depths. Okay, if you were to go by depth, what do you have? That's roughly what you get. Okay, so history of the moon. So what resulted from the moon resulted, they think, from a glancing blow collision of Earth and Mars. This is called the impact theory. So they think that Earth and, sorry, a Mars-sized object, I didn't finish my sentence. Earth and a Mars-sized object slapped into each other about 4.5 billion years ago, they think. And this little chunk went off, and that's the moon.
I just want to say Earth won that.
That's
by
one
the way.
theory. Mhm. So heavy bombardment causes what? What does the heavy bombardment of the moon cause? We just looked at it. Drew? Maybe. Yeah. Okay. Yeah. Well, regolith, which is this loose ground up surface. Okay. So when you look at the moon, it looks like a gravel and dust, right? It doesn't look like our soil. They call that regolith. So it's got a layered structure with a crust, mantle, liquid mantle, solid core. And then the Maria are formed by lava filling what, Liam?
Impact basin.
Yeah, that's what they, Nick, I clicked in the wrong spot. Yeah, filling the impact basin. So the moon has been hit many times. They think that some lava filled up those areas and you get this nice smooth spot that look like seas. So they call them Maria. And then they don't believe the moon is tectonically active, but they do know actually that there's about one moonquake every year.
How do they know?
They can monitor it pretty closely. Yeah.
With the regolith not looking like normal Earth soil, one reason for that is A, the types of rocks there. B, most soils on Earth are partially made up of organic matter.
Right. We've been through that. Mm-hmm. Yep. Very true.
Are there video of the moon earthquake?
I don't know if there are any video of moonquakes. That's a good question. Yeah, that's a great, yeah, we could look it up. I don't know.
That would be.
That would be cool to see. So this is your moon formation theory. This is your impact theory. And it kind of gives you like a little diagram. Boom. They think that's kind of what happened here. And then Earth kept going. And then of course you get, oh, why did it become a ball? What's that process called again?
Gravitational compactation.
Close. Yes, contraction. There you go. Yes, gravitational contraction. So then it spins around. Woo, look at these pieces. Oh my goodness. They're all sucked together here. There's your gravitational contraction at work. See? Tightening up. Yeah, of course, there are gonna be some pieces that float away. Now, this is cool. All right.
I wanted to see.
The sun, moon, earth system. So how they all work together. So there are daily motions, Earth's rotation, and then there's this thing. This is the Foucault pendulum. And this kind of, it's a good way to show the Earth's orbit. Okay. So this guy shows you a great example, and it's really pretty darn cool. Dartmouth are smart people. This is Jim LaBelle.
Foucault pendulum is the pendulum with a specially designed pivot, designed so that it can swing back and forth in any direction around the vertical. So that's in contrast to, for example, a grandfather clock, where the pendulum has to swing in a particular plane. Let's imagine that you have a Foucault pendulum at the North Pole of the Earth. When you set the pendulum swinging, you determine a plane in which the pendulum is swinging, and that plane is fixed. So as the Earth rotates underneath the plane of the pendulum swing. And so if you now go back and imagine that you're standing on the Earth, you see the plane of the pendulum rotate every 24 hours. Now, as you go to the lower latitudes away from the North Pole, the time that it takes the plane of the pendulum to rotate around lengthens. And in fact, at the equator, the plane doesn't rotate at all. At the latitude of Hanover, it takes 35 hours for the plane to rotate. So if you look at this pendulum here, if we look at it in a few minutes from now, we won't even be able to detect that the plane of the pendulum swing has changed. But if you come back in an hour, you will definitely see that it's moved a little bit. And if you come back in 9 hours, this plane of this pendulum here will have rotated by 90 degrees, a very distinct change that you can easily see. Plane of the pendulum swing is also affected, for example, by the revolution of the Earth around the sun. And so, for example, if you have a Foucault pendulum at the North Pole of the Earth, not only will it rotate around every day because the Earth is rotating, but you will also get a much longer rotation over the period of a year from the revolution of the Earth around the sun. So if you think about it, this Foucault pendulum here is a kind of rotation meter, a way of measuring rotation. A suitably placed Foucault pendulum can be used to detect the rotation of the Earth, or the rotation of the revolution of the Earth around the sun, or in principle, you can use a suitably oriented Foucault pendulum to measure the rotation, for example, of the solar system around the galaxy. So this brings up the question: the Foucault pendulum is sensitive to rotation, but rotation around what? And there's been a lot of speculation in physics and philosophy about that question. Ernst Mach, the 19th century and 20th century physicist, put forward the conjecture that the Foucault pendulum is measuring rotation relative to the universe as a whole. Makes a kind of interesting connection between a local physics experiment here in this room and the universe as a whole. The problem that people bring up is, how can this pendulum here somehow know something about the entire universe? So it remains as an unproven conjecture, more in the realm of philosophy than in physics at this point.
So you saw it was like a giant compass on the floor, right?
They probably should put one.
Somebody probably has, at least for a temporary experiment, but you can see that as that pendulum swings, it's gonna just, you've seen people do the art that, right? They put the paint in it and they let it go and you can see it swing.
Is it go on forever?
Well, now we get into law of conservation of energy, right?
Eventually it'll stop because friction.
There's friction in the air, so it cannot go on forever. But they have set it up so that it has as little friction as possible and it has as much free motion as possible.
Then we'll have one at Coastside in Ohio.
They do?
Science Museum, yeah.
Oh, yeah?
In the lobby, they have one that'll knock over like little marble.
Oh, yeah. I have seen them where they do that, where they'll knock over little things and you can tell where they've rotated, which is pretty cool. Oh, so your day length,
Just these little babies.
noon to noon is what? But in actuality, the length of a day we observe is 4 times longer than the time it takes Earth to rotate on its axis. So noon to noon is, yes? A solar day. Yep, it's a day. That's what we call a day, noon to noon, basically, or midnight to midnight, or 3 to 3, right? In actuality, the length of a day we observe is 4 minutes longer than the time it takes Earth to rotate on its axis. Okay, so we can't possibly have any sort of workable, practical system if we added 4 minutes every day. Can you imagine how kooky that would be? So what do we do about that? How do we deal with that? What is it? Leap year. There you go. Leap year is how often? How often is leap year? Every 4 years, we have a leap year. And what day do we add? What day do we add?
February 29th.
February 29th comes once every 4 years. That's because a day is actually 4 minutes longer than the 24-hour time we give it. Shh, shh, shh. Yes. Mhm. Oh, that's interesting. Did you have something too?
February 8 days, so it's gonna be 2 months, 30 days, 2 other months, 30 days.
Oh, don't ask practical questions, Bailey.
That's a problem.
I have no idea, but I bet Google could tell you because I'm sure there's a reason. Uh-huh.
That's too many questions. That makes too much sense. How dare you?
Could have done lots of things, but
Talking about all the different-
there you go. There you go.
Big Devin, working as one.
So the Earth's tilt is about how many degrees, Milo? Look at that, 23.5 degrees. And there are 2 points in the orbit when the Earth is farthest from the sun, and these are shortest and longest days, depending on the hemisphere. What are these? Caitlin? Yeah, okay, so we got our solstice. These are our 2 points when it's farthest from the sun, shortest day and longest day. And what are the 2 points when it's closest to the sun? Let's see, who hasn't answered me? Parker. Do you know what it is? When it's 2 days, the 2 points that it's closest to the sun, not the solstice, but the other one. Starts with an E. Sit down. Close. Equinox. All right, equinox. Yeah, equinoxes are the 2 points when Earth is closest to the sun, and those are equal days and nights. That equal, you can see it right there, like Caitlin just said, equinox or equi, right? That means your daylight hours and your darkness hours are exactly the same length. Okay, so that's what we get. Whereas at the solstice, you have the most daylight you can possibly get, right? Right. So changes in altitude. What is the sun's maximum height at noon? What do we call that? Piper. You forgot. That's okay. You tried. Oh, Lily's not here. All right, Yusuf, what is it? Not sure. Bailey. Did you know? Chloe, do you know? Does nobody know? What's it called when the sun is at maximum height? Yeah. Oh, there it was. James? What? Noon is the zenith. Okay, there's your word. Zenith is your sun's maximum height, and it's at noon. Or that should say at noon, not a noon. Ooh, I caught it. Alex didn't catch that. Yes. All right. So yes, that is going to be your zenith. Zenith is also the name of a television, and they made a lot of electronics. I don't think they even produce anything anymore, but. Oh, I don't know about that. I don't know what that is. All right, so synchronous rotation, the moon spins exactly once as it orbits Earth, okay? So your phases of the moon, you have when it's becoming more visible and it's becoming less visible. So when it's becoming more visible, what do we call it, Caitlin?
Waxing.
Waxing. And then what do we call it when it becomes less visible, Chloe? Waning. Okay, now I will tell you this. It might be a great benefit to you to be able to label a diagram that shows phases of the moon. Because you have a final exam coming up. So it might be helpful. So we start here. Let's start with a new moon. All right, which way is this going? Clockwise or counterclockwise?
Clockwise.
Starting with the new moon, which is when there's no light. Counterclockwise. So the first thing you get is a waxing crescent. Oh, look at that. And then your first quarter or a half moon. Now, here's the thing. Yes, it's a half. Why is it called a quarter? Because it's a quarter of the phases.
Oh,
Right.
yeah.
Then you have a waxing gibbous. Ah, fun word. I always think about those apes, the gibbons. That's where my brain, I don't know why, probably because I'm a biologist by training. And then you get full moon, then a waning gibbous, then your 3/4, because this would be 1, 2, 3/4 of the cycle. And then your waning crescent, and you're back to a new moon. Alex,
What type of wax is used for waxing the moon?
that turtle wax, it's really good. I recommend it.
Cheese
Uh-huh.
wax.
Liam?
Your wax?
Why, I think the full. Because then it's.
Mm-hmm. Well,
Because
it's
again,
because
it's
this is when the light comes again.
Okay.
So they kind of, they tend to start it here. Sometimes they start it from full. You should be able to look at any phase. Shh, listen, you should be able to look at any phase and know what's next, know where you're going, okay? Whether they're in a circle or a line or however it's set up. And here's the sun. It's important to know where the sun is, right? Because if you don't know where the sun is, you don't know what direction you're going, right? Uh-huh.
Small pet peeve, but why do we have? the
Shh,
sun
I'm sorry,
on
hold
the
on.
right,
Wait, say it
but
again.
why do we have the sun on the right, but for the bottom ones, the light is on the left? That is physically impossible.
What? The light is on the left. Oh, yeah. Oh, yeah. That's a good
It's
question.
Looking at the moon dead on. but you
It's
have-
because the moon would have,
It's pictures looking
Right.
at the moon dead on, but the sun is on the right and it's.
because this is what you're seeing from Earth, though, not what you're seeing from the sun. It's what you're seeing from Earth. Yeah. So we know about,
Very specific.
so we know about how the moon changes shape, which we watch. You can watch it. About how long does it take for the moon to change? Do we,
28 days,
hang
I
on,
believe.
go ahead. Yeah. Yeah, 29, 28 days, roughly what on our calendar?
Month.
Other people have a chance. Yes, roughly a month. Okay, so this is where we get our months. Uh-huh. Hang on. Shh. Mhm.
But what about blue cheese?
So this is how we, yeah, so the moon's gonna change shape based on how much of the sun's light it's reflecting at us, right? But what about the color? All right, so this I love. I want a print of this.
Like, cautious.
Okay, so I'm gonna read this to you while you marvel at the gorgeous picture. I really want a print of that. So what color is the moon? It depends on the night. Shh. Outside of the Earth's atmosphere, the dark moon, which shines by reflected sunlight, appears magnificently brown tinged gray. Viewed from inside the Earth's atmosphere, though, the moon can appear quite different. This image highlights a collection of apparent colors, meaning what we see, right? Apparent colors of the full moon documented by an astrophotographer over 10 years from different locations across Italy. Shh. A red or yellow colored moon usually indicates a moon seen near the horizon. There, some of the blue light has been scattered away by a long path through Earth's atmosphere, sometimes laden with fine dust. A blue colored moon is more rare and can indicate a moon seen through an atmosphere carrying larger dust particles. What created the purple moon is unclear. It may be a combination of several effects. The last image captures the total lunar eclipse of 2018 July, where the moon in Earth's shadow appeared faint red due to light refracted through air around the Earth. The next full moon will occur at the end of this month, where they're doing here. And in some cultures, they call it a beaver moon. So whatever was next was going to do something they called a beaver moon. You've heard it, there's like a blood moon, there's a blue moon. And this is what we're seeing. And truthfully, this is probably the prettiest collection of moon pictures I've ever seen. And it's a fairly recent one.
Those
Uh-huh.
ones up at the top, like there's.
Hang on, wait. Alex interrupted you, which was really rude. Go ahead, Yusuf. What were you saying? Oh. Huh, you seen that? You guys have seen that? Yeah, that could, because there's particles in the air. So that's in the atmosphere. Mm-hmm. Yeah, that one's really green, isn't it? It's interesting. It's just really, really cool. I want to see this one. This is the one I want to see. Yeah. Did anybody see the eclipse that we had back in 2018? Everybody see it? Okay, the next eclipse.
No, that was a solar.
That was a solar eclipse, right? The next big solar eclipse, right? Which is when you're going to have your moon block the sun. Okay, that's going to occur. Anybody know when? Does anybody know? It is next, 2024, and it's in October, I think. And it's going to go from like, it's going to arch. The path of it is going to be roughly in the US from down here in Texas, and it's going to come through like Arkansas, St. Louis area, Detroit is going to be right in the middle of it, and it's going to go up this way all the way through Nova Scotia. And there are some cities that are going to be dead in the middle. Now, we were talking about going again because we loved it so much when we saw it the first time, because we went to Totality, which is just up the road, right? We just went up to Toccoa, and that was Totality. I highly recommend, if you have a way to do it, go, because seeing it in totality is astounding. And I will tell you this though. Yeah, we tried to look, like we looked at Waco and Dallas because Cole's going to be there next year in school. So we're like, oh, we'll go visit Cole and we'll just, we'll stand there and see the eclipse there. You can't find a hotel now, already gone. Airbnbs are like a house for $3,000 a night. Like people are not playing. Yes.
We've actually tried to see one up in South Carolina.
Mm-hmm.
Stupid clouds.
Yes, but it was really, really freaky because the clouds. Because we had clouds, so we couldn't see the sun, but everything just went dark.
Yeah.
Animals were going crazy.
Yeah.
Thinking it was nice.
That's what it was when we saw it.
Weird.
What were you gonna say, Bailey? Yeah, the light was weird. It was like a kind of strange green light if you got to see it in totality. Yeah, it was weird. And then you get the whole like diamond ring thing where it's just shining off one side. It's really great. So lunar motions, new moon to new moon. How many days? We said it. Bailey said it. Yeah. 28, roughly 27, 28. Elliptical orbit. So this is your rising and setting 50 minutes later each day. So if you watch the moon rise, which is what it's called. If you watch the moon rise and then the moon set, it's going to change by about 50 minutes each day. Tides, you guys know this because we've talked about it before, but the moon's gravitational pull on the surface of the earth is what causes tides. Now, there are a type of tide where the sun and moon are aligning and it's causing increased gravitational pull and higher tides. And what are these called? Milo. There you go. We got our spring tides. And then what's it called when the sun and moon are at right angles and it causes lower tides? Liam, neap tides. Okay. Here's the thing to know. If you look at this one right here, okay, you've got the sun and the moon together. So you're increasing the gravitational pull of all this water. So if you're near water, that water's going to get like, right? And you're going to get higher tides depending on where you are. Some places are going to get low tide, like over here, right? And in this case, it's going to be the other way around. So you've got a right angle going on. So if you live over here, you've got a spring tide. If you live over here, and that's a high tide, or you got a low tide if you live down here. And then up here, you got you a neap tide. You got higher over here, but low over here, not as high or as low. See, still high and low, but not as high or as low. I have a good friend, actually Drew's godmother. She was born and raised in Beaufort, South Carolina, and she planned her wedding date based on the tides because their reception was at a place that was out near Beaufort is like, it's kind of like Savannah. It's right on the water and there's all these like marshes and whatever. And it smells when there's low tide because there's just mud, right? And dead sea creatures and algae. But when the tide's high, it's beautiful and doesn't smell. So she got married when the tide was high. So she specifically planned her wedding around the tide. I guess that's what you do when you grow up in a place like that, you know. So here are our different eclipses, right? So when the moon passes between the sun and the earth, which is affected by Earth's tilt, the moon crosses an elliptical plane. What's this one? Piper? This was close. Yeah, that's your solar, right? So this is your total solar eclipse looks like this. And if you went to totality, this is what you saw. And it was amazing. So when the moon is near apogee and occurs smaller, but doesn't completely block the sun, what's this one called? La, 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 la. Milo. We have annular is what we call it. And then lastly, when the moon passes through Earth's shadow, this one is a, wow, everybody's up. Okay, Yusuf. Lunar, right, cool. So here are diagrams of how they work, which you guys are probably pretty familiar with, at least your total solar eclipse. You get an idea of what that looks like.
It's the perfect time to do blood sacrifices.
Yeah, now here's an interesting thing. This doesn't happen. A total eclipse like this doesn't happen anywhere else in our solar system because the moon and the earth are exactly the right size that when the moon is in front of the sun and blocking the sun from earth, it appears like this to us, but it doesn't occur anywhere else. So if you want to talk about things that are perfect about earth, that's pretty darn perfect. You don't get that anywhere else. Now, I did wonder when I was standing there in the total solar eclipse, absolutely amazed by the whole thing. And then, like you said, animals were freaking out, cicadas were out making noise, crickets were chirping. And I'm thinking, imagine being somebody living several thousand years ago, and that happens.
The panic.
It's the end.
Yeah. Now, for those that kept calendars that were very, very accurate, and certainly some civilizations did, they knew it was coming, right? They had all the little reflecting things and shadows and Stonehenge like whatevers, and they had a clue. But if you didn't have a clue and that happened, it would be total panic. I cannot imagine. Yeah. So it basically appeared to be night, dusk, and then night. So animals that are nocturnal, specifically insects like crickets and cicadas, started making noise as it got darker and darker and darker, and then stopped when the light came back, which was very weird. So what's the location in the moon's orbit when it's closest to Earth called? Piper. When it's
Perigee.
here you go. Perigee, that's right. And then what is it called when it is furthest from Earth? Oh, Parker can answer this one. What's it called when the moon is furthest from Earth? Furthest. It's closer or further. That's it. What is it when it? Come on, Parker.
You got this.
Everybody help him. What is it? Apogee. There we go. All right. All right. So we're going to answer some of these together. All righty. Let me move this over. So if you have it, open it up. All right. Number one. Lily, do you have it? Number one? This, I don't know what the page number. Shh. Yep, there you go. Whoop. Dropped money somewhere. All right, so yes, the click. Come on, I'm clicking. Oh, Lord have mercy. It's gonna be stupid. Hold on. Whoop.
Start on the next pages.
I know, well, some of them I didn't do, others I did. Sorry. It's being stupid. I'm trying to get the magnifying glass to go away. Sometimes it takes it a minute to just kind of resettle itself. Shoot. Stop. Still have a magnifying glass. Okay, go away. Oh my goodness, go away. Sorry, I'm gonna fight with it for a minute here. There we go. Electromagnetic radiation. There you are, Lily. Consists of electric and magnetic disturbances or waves that travel through space. Human eyes can see one form of energy called, Milo, visible light. All forms of electromagnetic radiation, including X-rays and radio waves, make up the electromagnetic spectrum. Where the heck is your? There it is. Each type of radiation can be classified in two ways. What's the next one, Liam?
Frequency.
Wavelength is the next one. Measures the distance between peaks on a wave, and what is the number of waves that occurs, Jack?
Frequency.
Frequency there is the number of waves that occurs each second. Scientists study radiation with Lily. There you go, telescopes. Bum, 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 which collect and focus light. What's the next one gonna be? Who's got it? Number 7, Milo. There you go. The larger the opening that gathers light in a telescope, the more light that can be collected. What do you call the opening in a telescope? Same thing in a camera. Does anybody know what it's called?
Oh,
James? The what? Well, the lens is what's going to collect the light, but the actual part that opens and closes. Do we know what that is?
oh.
Oh. Who knows? All right, Liam, what is it? That's one word. There's a better word.
Aperture.
Aperture. There it is. That's what I'm looking for. Aperture.
Okay, the aperture from portal.
Mm-hmm. All right. Whatever that is.
Takes a lie.
What's number 8? What? Bailey? Yep. A refracting telescope uses, we're so crazy today, uses lenses that bring light to a focus. And what uses mirrors? Milo? Reflecting telescope uses mirrors to do the same thing. The process of linking several telescopes together so they can act as one is called, Yusuf? Yes, interferometry. Very good. All right. So the first multi-country space habitat for long-term human occupation is what? Oh boy, everybody, Piper.
International Space Station.
Okay, very good. Now, here's something to know. You can get apps, various apps. There's going to be an app soon that you're going to have to download for a lab. Starwalk, correct. Where you can see when ISS is going to pass over. Who has seen ISS before? Watched it? Anybody here who hasn't seen it? Oh, a lot of you haven't seen it. Okay, so on a clear night, you really can't see it during the day. On a clear night, when ISS is making a path, if you get, there's a couple apps that'll do it, but if you get one, it'll tell you what time to expect it, where in the sky it will start and where it will end. Like it'll say, it'll come up the northeast and you can watch it. You can watch it go over because it's reflecting the sun's light. And it's usually like kind of a white or sometimes almost yellowish little dot. And it's weird because you're watching it go by and you're like, there are people in that. There are people up there. All right, so what is the probe to Mars? Liam.
Curiosity.
There you go, Curiosity. No, Pathfinder, sorry. One more thing I'll say about ISS. Yeah, Curiosity is the newer one. Yeah, but out of these, it was Pathfinder. One more thing I'll say about ISS. If you know anybody that does ham radio, you can contact ISS and talk to the astronauts, and that's pretty darn cool. It has to be, ham radio is like the shortwave radio where you can talk to, anybody ever seen Contact, the movie Contact, or read the book? Anyway, it's you can talk to people like you could. It's a radio, but you use it to talk to people.
Like things
Yep.
truckers use.
Like a CB, sort of, but you're using it you can pick up stations and signals from very, very far away. And you can talk to ISS, which is really, really cool.
What you guys eat for lunch today?
Yes. Oh, you're doing the next one? So, so telescope launched in 1990 to carry out observations in visible light, infrared, and ultraviolet wavelengths is Yusuf? Hubble, right? Yes. All right. Craft in which astronauts study weightlessness, growth of crystals, and other phenomena. Lily. Space shuttle, right? Is there a space shuttle anymore? Nope. What was the last one? Last launch.
I believe it was like 2014, 2016.
It was Atlantis as well as which shuttle. They retired the shuttle program because it was expensive and
They exploded it.
well, not a lot,
Let's figure out how to not make them explode. They did.
but it did happen.
Yeah, there were a couple.
So lastly, for this one though, telescope used to observe X-rays blocked by Earth's atmosphere is Milo. Yeah, observatory. So yes, here's the thing with the space shuttle. So typically the crew was 7 astronauts. They would put them on, they'd launch them up to space. It was like an airplane. It landed like a glider. Okay, so it got launched by rockets. It had boosters. So it had 2 solid rocket boosters and then a liquid fuel tank, which was the big kind of reddish orange thing that ran up the middle of it. And then down the sides were the white solid rocket boosters. It would go up, solid rocket boosters would come off. Eventually you'd lose all of it. And then they'd
Fuel tank
orbit. Yeah, in orbit, they'd do whatever they were going to do. And then when they came in, they would
landed kind of
like a glider. Yeah, they didn't really have any control. It was all glider. Just kind of glided in, right? It was pretty cool. It was really actually a really cool thing. The last launch actually was the second to last launch. They ended up doing one more. Jason and Cole went and my father-in-law went and they went and watched it because it was a pretty cool historic thing, which is super neat.
that one that exploded.
Now,
Yeah.
there are 2 space shuttle explosions, and then there were also some, guys, there were also some issues on the launch pad with other ones. Initially, we had capsules, right? We would send them up on a rocket with a little capsule on the top, which is similar to what we've done with some of the stuff now that SpaceX has done. It has Dragon, right? And then Dragon drops into the ocean. That's what was done initially. Alan Shepard actually got stuck and almost drowned in one of the initial capsules. Y'all all right over there? You're losing it. Now,
None of us are all.
the 2 that exploded,
You know what?
yeah, the 2 that exploded, what are they? Do you know? What was the first one in the 80s? You know? Do you know?
There's a picture of Macaulay Culkin.
No, it's not Macaulay Culkin. It's the kid, it's Peter Billings, the kid that played Ralphie in A Christmas Story was there. Correct. Do you know the name of that shuttle that exploded in the 80s?
Heard of it, I just can't. think.
You know? Well, hang on. I'm asking it. Well, yeah, like yesterday we had a launch, huh? Okay, it was Challenger. All right. And the unique thing about that launch was they had a non-professional astronaut on board who was a public school teacher named Krista McCullough. There was a competition to get a school teacher to ride the shuttle and then come back and teach about space. It was a big whole campaign. It was all of this publicity. We're going to send a professional teacher up. They had to train her, guys, they had to train her how to do all the astronaut stuff. And there's all these pictures of them walking in and she was waving. Hmm?
And she failed.
Well, she didn't fail.
We didn't fail.
On the way up, and you can watch videos of the Challenger launch. It's horrifying, but on the way up, there was an issue with, I believe, one of the solid rocket boosters, and the shuttle exploded during launch, and pieces of it went all kinds of directions. You can see the solid rocket boosters kind of flying off all over, but everybody was watching. The whole country, no joke, was watching this launch. There'd been plenty of launches that had gone on before and after that people didn't pay any attention to. Everybody was watching this launch because it had been publicized so much. I was in like 3rd or 4th grade, and it was the one day. So when I was in public school, they had like, you know, the gifted program thing, or like here, I think it's TAG or whatever it is. I don't know, because we don't do public school. But one day a week, I went to a different school. And that day was the day of the launch. And my class did not watch it live. The 6th grade class did. And part of the reason they watched it live is that one of the 6th graders knew one of the astronauts, which in Virginia Beach is not that uncommon because it's a Navy base. And a great many of those astronauts went through the Naval Academy or were naval pilots. So this person was a family friend, one of them. And it exploded with the whole country watching. And it was absolutely horrible.
School's out.
Cause she was like going to the library.
Yep, this is one of those cultural markers where you can say, where were you when something happened? Can you think of one in your life that everybody can relate to? Where were you when? Well, COVID was a big, long one, yeah, but I mean like a moment. Can you think of one? 9/11 is a great example, if you were alive then. Some of you were not alive yet.
Alive yet. I've heard stories of where
2002,
I've heard.
or no, 2001. No, yeah, 2001, yeah.
I've heard stories of when people where
Yep.
people were.
Can you think of another cultural marker? Yeah. Titanic is a great one. There isn't anybody alive that remembers that, but yep. How about you? Shh, hold on, guys. I still have issues with my voice. I don't want to yell. What were you saying? Queen Elizabeth's death. That's a good one. Where were you when Queen Elizabeth died? I don't remember where I was. But yeah,
Russia invaded Ukraine.
Probably.
Russia invading Ukraine might be one. Some of the big ones. Some of the big ones, you could ask, most of you could ask your grandparents, where were you when, hang on, yeah, D-Day. Where were you when John F. Kennedy was assassinated? Almost every one of your grandparents will be able to tell you exactly where they were and what was happening. Where were you when the Challenger exploded? That's a big one. Mhm. Where were you when Columbine happened? That's a big one. Columbine was one of the first heavily publicized school shootings. And cultural markers are things that tend to, everybody can relate to them, and then they have an impact on what people do or how people behave from that point on, or how people think of a situation from that point on. So those are some of the really big ones. And where were you when man landed on the moon? You could probably ask your grandparents that one as well, because most of them would have been alive for that. Yeah. The sad thing is, yeah, Sandy Hook is a very good example. I can tell you exactly where I was.
Hurricane Katrina.
Yep, I can tell you where I was for that too. Wasn't alive for that.
I missed that by a few years. Can you tell me what happened?
Okay, so
By at least 2 days and 3
Caitlin.
hours.
When man landed on the moon, it was our grandpa's birthday, right?
July 20th. Cool.
That's my birthday.
Is it?
Yeah.
That's only a week away from.
Yeah. What were you gonna say? When Pluto was no longer a planet. Yeah.
It became free from the solar system oppressing it.
So let's run through the second page and then we'll do the last one together. All right. So
That's 6, August 23rd.
y'all can answer. Y'all can answer together. Temperatures on the moon's surface are always very hot. The light colored mountainous regions of the moon are called highlands. The dark smooth plains of the moon are called Maria. Features on the moon formed by objects crashing into its surface are impact craters. Let me finish the sentence. The material that falls back to the moon's surface after the impact blast is ejecta. Long trails of ejecta on the moon's surface are called rays. Meandering valley-like features on the moon's surface are called, well, look at that, I don't have that one. Oh, it's not circled there, but you're right. There is no erosion other than surface creep and erosion due to impacts on the moon because there is no atmosphere or flowing water. After a long period of impacts, the moon's impact basin filled with lava. Scientists hypothesize that the moon's crust is twice as thick as, on the far side. The layers of the moon from the surface inward are crust, upper mantle, lower mantle, core, just like Earth, right? According to the most commonly accepted theory, the moon's formation, the moon is made from materials from Earth and the body that hit it. The most commonly accepted theory about the origin of the moon explains why the moon and Earth have similar compositions. Okay, so, oh, look, here we go again. Great practice. So what is being shown here?
Waxing crescent.
How do you know?
It's on the right side.
On the right side, waxing crescent. And this one would be
First quarter.
first quarter. Why is it quarter and not half?
That's the different half bar.
Talking about the cycle, not the
Then a
appearance.
Point where it hits a multiple of 1/2.
Mhm. Sometimes this will be called a waxing quarter, just so you know. Liam. All right, how about number 17?
Waxing gibbous, or waxing anti-crescent.
Waxing gibbous, anti-crescent. And then we have full. Okay, so 19 is waning gibbous,
Anti-crescent.
20, third quarter or waning quarter. Okay, and then 21 is waning crescent. Okay, why is the moon invisible from Earth during a new moon? Bailey. Bailey. You're not Bailey. Are you Bailey? Bailey.
Bailey.
But because there's no sunlight hitting it, so you can't, because you see the sunlight reflected off the moon.
Mm-hmm.
So if there's no sunlight in it, you see it.
What's blocking the light?
Us.
Yep, you got it. Earth is us. Earth is blocking the light. Okay, excellent. So what I'm gonna do is I'm gonna send out some information to help you with the lab. And like I said, it will be extra credit if you turn it in instead of just whatever, because that got wacky today. Anybody have any questions about anything? You need to look ahead to the labs that are coming. All right, look ahead, see what's coming. We've got a lot of stuff coming up with can fix this.
My internet is down, so I probably won't be able to check.
Your internet's down?
Oh, no.
I hate it.
Totally?
I-
Do you have cell phones?
Yeah, but usually only one parent's.
Okay, so it'll be out by tomorrow. So I hate that when our internet was down off and on for like 3 weeks. So it'll be out by tomorrow. So sometime tomorrow, check and see what you get. Okay, and then you'll know. And you can always if you've got internet down, a good thing to do is always you can go to, oh, what are we doing? You can always go to like a library or a Starbucks or whatever. I've been known to do that. So,
Oh, yeah.
all right, you guys, you are good to go.
I think that bird in the window gave itself CT.
That bird is going to be brain dead. Bye, Sky. Catch you later. Let me turn it around so y'all can reach it. Hold on. Let me just turn it around. Yes, ma'am.
Okay, thank you. Oh, yeah. Space shuttle, so you better go.